What was that, Paul?
I don't know.
Making faces. You were making faces.
I was making faces.
You were indeed. It's pretty ugly. Anyway,
It's what we do.
it's what we do. Hey, good evening, everybody, and welcome back to our Sunday night offering of astronomy outreach edutainment, the Sunday Night Astronomy Show.
Yay.
Hey! Okay. Line two. First of all, I'd like to welcome back Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton. Hey, Paul.
Hello, hello.
And Mr. Mike Powell from the PFO Observatory right here in St. John, New Brunswick. Hey, Mike.
Line 3.
Yes, sir. Okay. So this week on Sunday Night Astronomy Show, now, is the moon really round? Is there gravity on the International Space Station? Well, we're busting out some of the strangest space myths and uncovering 21 fascinating facts, SP21, about the universe that might surprise you. Plus, Mike returns with the new binocular target of the week. Paul shares another interesting Rosanna's fun fact. I'll show you a little bit about what's up to watch for in the night sky this week, along with your astro photos. So sit back, everybody, and enjoy. And remember, this is a family-friendly interactive broadcast. And we are live. So let's get started, guys. Who wants to start? Not me.
Mike.
Greetings from cold Yarker, Ontario. Oops. Sorry to hear that, Kevin.
Yeah. You
See
got
if I
that
can get-
nice yellow presentation. So yours is
Get my
nice.
screen to move here.
Yeah.
And then I pull up this one and say start to share. We figured out how to do this. I think it goes to here. We should see something up there that looks cute.
Here we are.
There it is.
Ah, we have me. Okay. So, some space myths. And of course, my coffee shaken from the earthquake that was in Ontario last week. So,
Oh, I thought you had a cockroach in it.
well, that could be too. All right, myth number 1. The moon is not round. The moon is actually lemon-shaped. Despite its appearance in the sky, our natural satellite is nowhere near round. In fact, the moon is shaped like a lemon, with flattened poles and bulges on both sides near and far side around the equator. Its strange shape is thought to have been created during the interaction with Earth after its formation. So the moon is not round. I don't think it's quite like this, but that's exaggerated. It is more lemon-shaped than round. Mercury. On Mercury, a day is twice as long as a year. Now, how do you figure that one out? It says technically, the Mercurian day lasts 59 Earth days, while a year lasts 88. However, due to Mercury's very eccentric orbit and alignment with the sun, the length of time from sunrise to sunset, known as a solar day, is equal to 176 days, twice as long as a Mercurian year.
And it's probably a Monday.
Probably a Monday, yeah, for sure. 1 teaspoon of neutron star weighs the same as the human population. A neutron star's density is mind-boggling. The stars are composed almost entirely of neutrons packed together into tiny radius. Just a teaspoonful of neutron star would weigh over 1 trillion kilograms. That's much more than the weight of the entire human population when it reaches a few 100 billion kilos. To make something as dense as a neutron star, the whole of humanity would be needed and crammed into the space the size of a sugar cube.
Oh,
That's crazy.
Oh, lost your screen, Mike.
lost your screen there, Mike.
Lost my screen. I'm seeing it. I'm seeing it on Facebook
Okay.
Hang on.
so far.
Hang on.
See,
Let's go back.
oh,
That was
just
me,
here. Now it's
probably.
just
There we
back.
go.
Oh, okay. Neptune has only completed 1 orbit since its discovery, of all things. This Hubble image in 2016 shows many new atmospheric features compared to those that were discovered by Voyager 2. One of the favorite facts about space, perhaps the most memorable, if you want to impress your friends next time you're sharing a cool fact, Neptune takes a whopping 165 years to complete 1 full orbit around the sun. Since it was discovered in 1846, Neptune has only finished its first full post-discovery orbit in 2011. demoted planet Pluto has yet to match this. It's not even close to completing one full 248-year orbit since its discovery in 1930. So that's kind of cool that Pluto hasn't even done a single orbit since the time we found it.
Wow.
Is there gravity on the space station? Fresh fruit is always a welcome treat after a visit from the Earth's resupply ships. Here's a shot of astronaut. Is he now a senator, this fella? I think so. Footage of astronauts in the space station give the impression of gravity-free environment, but onboard gravity is actually only 10 to 11% weaker than the Earth's surface, believe it or not. This particular one of our facts related to common belief that there's no gravity in space. Astronauts float freely on the space station due to a continual state of free fall in orbit. The same effect experienced by skydivers. The difference with the ISS is that it's in horizontal motion. As the ISS moves sideways and falls towards the Earth, the horizon curves away beneath it at the same rate, keeping the ISS in orbit, simulating the feeling of weightlessness for someone on board. So it's just literally in constant free fall. And that's why you don't get the sensation of gravity. But I thought it was cool to find out that it actually is only 10 to 11% weaker than the gravity on Earth.
Yeah.
Wow.
Here's a big star.
That's
I don't know how you pronounce it. I think it's Scuti. But 5 billion suns would fit in UY Scuti, one of the largest known stars. Compared to the rest of the worlds in our solar system, even colossal Jupiter and to our sun is pretty big, but nothing compared to the biggest stars we know of. Red hypergiant stars would positively dwarf our sun if there was a cosmic "Who's the Biggest Star" contest. UY Scuti is such a stellar giant, it often refers to as the biggest known star in the universe, although it hasn't been definitely proven. But calculations reveal that Scuti replaced our sun. The outer edges would sit at the orbit of Jupiter. 5 billion suns, 7 trillion Jupiters, and 7 quadrillion Earths would fit inside Scuti. Wow. What's more, Scuti is 300,000 times bigger than our sun, but it's so far away, you wouldn't know it when you're observing it at night. So that's pretty darn big.
That's big.
It's the big boss.
Oh, meteorites. I thought this one was cool. We discussed it just a little bit before the show. Meteorites are hot, but you can probably, by the time they land, they're not. So as a meteorite passes through the Earth's atmosphere, they heat up so rapidly that the surface of the rock begins to melt. However, it is a bit like searing a steak. Although the outside becomes intensely hot, the inside actually remains cool. The melted rock forms a crust just 0.04 inches or millimeter thick, and by the time the meteorite hits the Earth, it is likely to be cooled down enough slightly, just slightly warm to the human touch. So that's another neat one too.
That's cool.
But I suppose if it's slowing down as it's coming down in free fall, it cools off as well. You stick your hand out the window of your car in the wintertime, everybody knows what wind chill is. Well, it'd be the same as a hot rock coming through the atmosphere and slowing down, I guess.
Yeah.
Anyway, that's the end of her.
Hey, awesome.
He fell off the edge. But that's just that you might not have known.
Awesome, Mike.
See if I can find the share button here. Boom, that puts me out of business.
Interesting stuff.
Different.
Very different.
Definitely different.
Yeah. I did not know that.
I did not know that. You want to go next, Paul?
That story about the weightlessness, man, that was pretty heavy.
Yeah, didn't it? Oh, boy.
And you say my Bono Bud ones are bad. Wait till tonight.
They are.
Yeah.
Did you want to go next, Paul?
Okay. Let's see if I can do it here. So which one's which, I guess. Scary.
Top 7 for you.
All right. Can you see the screen? I'm sure you can.
Here we are.
All right. So my crazy fun information about space starts on Mars. So, believe it or not, the red planet has blue sunsets. So, blue sunsets on Mars occur because fine, iron-rich dust in the atmosphere scatters red light more effectively, allowing blue light to penetrate and concentrate near the sun, which creates a blue glow around the sun's disk as it sets. Unlike Earth's blue skies and reddish sunsets caused by air molecules scattering blue light, Mars dust scatters red light during the day, but at sunset, increased atmospheric path makes the blue light the dominant color near the sun. Cool. So who would have thought? The red planet has a blue sunset. Interesting.
I did not know that.
I did not know that. Next up, Venus. So Venus rotates backwards and slowly. So it has the slowest rotation. Venus has the slowest rotation of any planet, with a sidereal day lasting roughly 243 Earth days. Retrograde spin. So Venus spins in the opposite direction, clockwise, to its orbit, often referred to as retrograde motion. So there you go. The slowest moving thing out there. Pretty as it is. Okay, let's get rid of, I'll let you talk about that. So there are more stars than the grains of sand on Earth. Astronomers estimate there are significantly more stars in the observable universe, roughly 111 sextillion to 70, I can't even read, there's so much, 70 septillion. The grains of sand on all Earth's beaches and deserts, roughly 7.57.57 quintillion. This means that there are likely thousands of stars for every single grain of sand on Earth.
Wow.
Wow.
Isn't that wild?
Thousands of stars. Wow.
So every time you take a step into that nice sandy beach, and as your foot elevates and all that sand grains that are dropping, there's thousands more stars than what's happening there. Isn't that wild?
Or when you get home and dump the sand out of your shoes, eh?
Yeah, just think about how many more stars are there. That's crazy. Okay, so footprints last forever on the moon. Sorta. Human footprints from Apollo moon landings 1969 through 1972 remain on the lunar surface, preserved for potentially millions of years due to the lack of atmosphere, wind, and water erosion. These iconic marks, along with rover tracks and equipment, are still visible to high-resolution orbiters, though they are too small to be seen from Earth. So there you go. So the largest volcano in the solar system. Olympus Mons is the largest volcano and the highest mountain in the solar system, located in the Tharsis volcanic region near the equator of Mars, towering over 16 miles, 25 kilometers high, nearly 3 times the height of Mount Everest. This massive shield volcano covers an area roughly the size of Arizona or France. That's a big volcano.
Yeah, it's a big volcano.
Venus is hotter than Mercury. So, although Venus is closer to the sun, Venus's powerful greenhouse effects makes it the hottest planet in our solar system. Yes, Venus is significantly hotter than Mercury because of its extremely thick atmosphere, primarily carbon dioxide, which creates a runaway greenhouse effect, trapping solar heat and preventing it from escaping. Unlike Mercury, which has almost no atmosphere to hold heat. While Mercury gets closer to the sun, its heat quickly radiates away, leading to scorching days but freezing nights, whereas Venus maintains a consistently scorching surface temperature around 475 degrees Celsius. Now, Mercury is only 167 degrees Celsius, and Earth, here we are on average 15 degrees. That is interesting. That's a hot place, that Venus. Now, there are over 1 million Earths can go inside the sun. So the sun is vastly larger than the Earth. Its diameter is about 109 times the Earth's, meaning you could line up 109 Earths across its face, and its volume could hold roughly 1.3 million Earths, with its mass being over 300 and 30,000 times greater, making up almost all the mass in our solar system. So there's a picture of the Earth in comparison, just a corner of the sun and just one of the flares. That's amazing. And that's it. That's what I have to share.
That's awesome, Paul.
Yeah.
I'm going to read a little comment here. Someone had mentioned about there's a huge solar flare happening right now, and there is. A major solar flare is currently in progress around AR 4366. At the time of this update, the X-rays are currently at X8,
Wow.
making it the second strongest solar flare in terms of peak of the current solar cycle. Cool. So,
Good on.
making the odd blip.
Get some clear skies.
Okay, I'm going to give my presentation a try here so I get things opened up.
All right.
I think it's going to go there, so I got to...
Here's a trivia question for you. Is there a mountain bigger than Mount Everest?
Olympus
Yes.
Mons, is it?
Mauna Kea.
Mauna Kea? Really?
Yeah. If you go from the ocean up, it's
Oh.
not. But if you go from the bottom of the ocean where it actually sits and up, yeah, it's 4,000 feet taller than Mount Everest.
Oh, I did not know that.
Mauna Kea, Mauna Kea.
Okay, I'm going to share a screen. It's going to freeze up here on YouTube for a second. But we're on, okay, ready? I'm going to share this one, I guess.
There we go.
There you go. Oh, okay. All right, so I'm going to keep going here with my interesting facts about space, I guess. I'm going to start out with this one. There is no sound in space. Well, it's almost a fact. Sound is like a mechanical wave that requires a medium like air or water to travel through. Now, since space is a vacuum, where am I? Sorry, okay. Since space is a vacuum with no atmosphere to vibrate, total silence is a rule. Now, in space, no one can hear you scream, as that movie says, or anything else. Now, there is an exception. The exception is gas clouds or nebulae that can carry sound waves, but they are at frequencies far too low for the human ears to detect. But there is another type of compression and rarefaction that doesn't require anything other than the fabric of space itself to travel through. Gravitational waves. Mechanical disturbances that ripple through the fabric of space-time, and their data can be converted into audible frequencies. Gravitational waves are in effect the sound of the universe because they are caused by vibrations of mass, like black holes colliding together.
Wow.
Scientists translate the low frequency vibrations of gravitational waves into audible sound waves, creating a chirp that increases in pitch as the black holes merge. While they don't need air, a powerful enough gravitational wave could physically vibrate your eardrum, effectively making it sound in that sense. So,
Wow.
that's why it's almost a fact, yes,
I hear you.
or almost a myth. Okay, the asteroid belt is a crowded minefield. This is a myth. We all seen movies of spaceship flying through minefields and bang banging with lasers and stuff, and that doesn't really happen. Trying to miss asteroids as they go through it. Movies show pilots dodging dense clusters of spinning rocks, but the reality is much lonelier. There are the average distance between two asteroids is roughly 900,000 kilometers,
Wow.
over twice the distance from the Earth to the Moon. That's how far apart they really are. Space agencies don't even need to plan dodging maneuvers. Hitting an asteroid by accident is pretty well impossible. So we don't worry too much about the asteroid belt. All right, the sun is on fire. Well, it is right now.
Yeah.
I don't say it's on fire, but anyway. And I got this one a lot with elementary kids because I just went to a class the other day and we were talking about this. So is the sun on fire? I asked, and they, oh yeah, it is. But no, it isn't. A fire is a chemical reaction that requires oxygen. And there is no oxygen in the vacuum of space, so the sun is not burning. It's actually glowing due to nuclear fusion. Hydrogen atoms are being crushed together by immense gravity to form helium, releasing incredible amounts of energy as heat and light. Apparently the sun releases more energy in 1 second than we have used as humans since we've been here. So there you go. not on fire. All right, next one up for me. Visible matter is only 5% of the universe. This is a fact. So everything you've ever seen, the stars, the planets, trees, and people, is just a tiny fraction of what's out there. And here's the breakdown. 5% of everything that's in the universe is normal matter, what we see. 27% is actually dark matter, which is invisible, the invisible glue that holds the galaxies together. And 68% is dark energy, the mysterious force that actually is pushing the universe apart. And it's actually speeding up the farther out you go. So we are living in a universe that is mostly invisible to us.
Oh.
95% invisible. Now these things, gamma ray bursts, most dangerous thing in the universe. This is the fact. A gamma ray burst, these are the most powerful explosions in the universe, usually caused by a collapsing star or two neutron stars colliding. Now a single burst can release more energy in 10 seconds than our sun will in its entire 10 billion year lifetime.
Wow.
If a GRB or a great gamma ray burst occurred within 200 light years of us and was pointed at Earth, it could strip away our ozone layer, causing a mass extinction. Fortunately, there are no stars within 200 light years of our solar system that are of the type destined to be great gamma ray bursts. So hold on to your hat, we're good.
Probably burn a few ants with that, eh?
I think so.
You would think.
Wow.
This one, light isn't affected by gravity. That is a myth. While light has no mass, gravity doesn't just pull on stuff. It actually warps the actual fabric of space-time. Hear a lot of that term a lot lately, space-time. When light passes a massive object like a galaxy, it follows the curve of warped space, causing it to bend. This is called gravitational lensing. It's a phenomenon that was predicted by Einstein's general relativity, where massive objects like galaxies or black holes warp space-time, acting as a lens that bends, distorts, and magnifies light from a distant background source. It enables the detection of dark matter, maps mass distribution, and reveals distant, otherwise invisible galaxies. So it acts like a lens, so there are galaxies back here that can't be seen, but here they are here. They're behind this group. So these are examples of gravitational lensing right there. Power of galaxies, gravitational pull. And I think this is my final one. So black holes act like vacuums. No, they don't. Not really. So black holes don't suck things in from a distance. They are simply objects with extremely high density and gravity. If you replaced our sun with a black hole of the exact same mass, Earth wouldn't get sucked in. We would continue to orbit it just as we do now, although it would be pretty cold. You only get sucked in if you cross the event horizon, the point of no return.
Oh.
Yeah, so not to worry. We're okay.
So we're safe.
Okay.
Yes, we are.
safe.
Stop share, and we're going to go to here. Oh, there.
Well, there.
So there we are. We were Mythbusters.
Mythbusters.
Mythbusters. Yes. Well, that's some pretty cool information.
Yeah. Awesome.
Yeah. Yeah, I think that's stuff to think about.
I
I did not know that. Okay.
And that's only a few. That's 21 things we ran through very quickly.
Oh, yeah.
And there's like a gazillion, kabillion out there of all the different things that we think are myths or not. Anyway, anybody out there who's got some, while we're here on the show tonight, if you want to share online and you got some questions or myths, throw them out there, see if people can answer them.
Sure. Yeah.
Kind of stuff. Or if you got a cool fact, put it on there, share it with us. That'd be fun to talk about.
Check out YouTube too, because there's a lot of videos with this stuff. If you're not quite understanding what a gamma ray burst is, or those type of things are there too. So, yeah, awesome guys. I think we covered that. Okay. All right, let's move on then to binocular target of the week. I keep saying it wrong. See, I'm used to it.
This one, I think. What should be? Show want to dance?
There it is.
Alrighty, binocular target of the week this week by Bino Bud. If you remember from this time last year, Lambda Lambda.
Ah. Lambda Lambda.
Lambda Lambda is a figure that is the shape of the Greek letter Lambda. The star Lambda Orionis is part of this asterism, which explains the suitable name. How would I find it in the sky? Well, it wasn't so cold. You went outside tonight at 10 o'clock, oriented yourself at 160 degrees southeast and looked up. You see Orion. You know where the belt is. Everybody knows where that is. We all know where Betelgeuse is. But you come across the top of that, the Orion constellation, and right here at the top is that star, Lambda Orionis. And guess what? That's good. Lambda is that, but there, that area, that star is part of it. How's that? Blah, blah, blah. Here you go. A little closer look. Comes down and splits this way, comes down and splits that way, and there's that star, Lambda Orionis. So Betelgeuse, I forget what this one is.
That's Bellatrix.
Bellatrix, yeah. And then Lambda Orionis, and there's Lambda right at the top of it.
So you say Betelgeuse 3 times and you say Lambda twice.
Exactly, Lambda. This is what it looks like. This is not my photo. I have photographed it, and I'll be posting it tonight after the show. But this is Lambda. You can see it comes down and goes one way, comes down and goes the other way. Can't miss it. 10 by 50 binoculars. She's a good size. Look at this. It stands out nicely. You see you can make out the lambda sign, no problem when you come across it. Compared to the full moon, it's 1.5 full moons. So it's a good sized target. Easy to see. Grab a pair of binoculars, get out, see if you can spot it. Now you ready for this one? I was telling you it's a bad one, Paul.
We're ready. What
is an alien with 3 eyes called? An alien. That's Binocular Tech of the Week by Bino Bud.
That's a beauty. Well done, Mike. All of it. Hey, we're moving right along, guys. We're going to have an hour to go. Man. We still got lots of time, so.
Okay. Well, I wonder if he had 5 eyes. Oh, that's hilarious. Oh, my goodness.
Well, let's move on into Rosanna's fun fact.
Yeah, we can do that. But before we do, you said that picture of Lambda that was taken. Was that your shot?
No.
Oh, okay.
I am posting one tonight after the show that I did take. So.
Yeah, it's a nice looking group of stars in a photograph. Yeah. I would have never thought to ever shoot that, but it stands
out really nice. It really does. Yeah,
it's beautiful. Awesome. All right, Rosanna. Okay, see if I can figure out how to do this again. Where's the share button on this thing? I lost it already. There it is. Share button. There we go. And this is this week's
Rosanna's Fun Fact.
Welcome back, Rosanna. We missed you last week, and we are so glad that you are back to share some more of your absolutely wonderful fun facts. So let's dig right in. So Rosanna writes, "Hi, Paul. These last 2 weeks of January have had some really exciting stuff for all of space enthusiasts. So let's start with the European Space Agency's Proba 3 mission." Now let me just get that photo up, and I have to move my phone so I can see where my photos are. There we go. If you remember from a previous fun fact, the Proba 3 mission is a dual probe technological scientific coronography. That's a hard one to say. Coronography. She always gets me. This is an artistic rendering of the mission. I would love to give the artist credit, but I could not find any information on it. The internet doesn't always tell you everything you want to know. So this Proba 3 consists of 2 independent 3-axis stabilized spacecraft, the coronagraph spacecraft, which is the CSC, and the other occulter spacecraft, the OSC. The spacecraft fly close to each other on a highly elliptical orbit around the Earth with an apogee of 60,500 kilometer altitude. By flying a tight formation about 150 meters apart, the occulter will precisely cast its shadow onto the coronagraph's telescope blocking the sun's direct light. This will allow the coronagraph to image the faint solar corona in visible ultraviolet and polarized light for many hours at a time. This is effectively a man-made eclipse. Just so you know, creating an artificial solar eclipse in space is not a very easy feat. Proba 3's 2 spacecraft must hold multi-millimeter level alignment so that the occulter spacecraft shadow falls exactly on the other spacecraft's coronagraph. Any slip in the sun's glare can easily overwhelm the faint corona. So think about that for a minute. That's pretty amazing technology when you think about that. The precision as to exactly how far it has to be away, how it has to exactly line up, and how long it can stay there and hold that pattern. That's unbelievable. Anyway, this amazing feat has been accomplished, and on January the 19th, the ESA released an animation of the data from the 2 spacecraft into a free downloadable GIF. Now I'm going to see if I can play that. You just hang on. Yeah, there it goes. So this is exactly what's happening. So this is essentially what's doing it. So it's creating this solar eclipse so that it can observe all of this stuff, but not just for a few minutes, for quite a little period of time. So it can do this to a lot of different things. So I'm assuming it's looking for stars of a certain size to work on. That's absolutely amazing. So and she also gave me a still photo of it if the GIF wouldn't work, and that's the still photo of it there. But the GIF worked, so that's fantastic. That's unbelievable. So the inner solar corona is yellow. In yellow is data from the Proba 3's Asphyx coronagraph, and the solar disk in the dark orange is from the Atmospheric Imaging Assembly aboard NASA's Solar Dynamics Observatory. Now, let's move on. Then, on January 26, this was released to the world. Scientists using data from NASA's James Webb Space Telescope made one of the most detailed high-resolution maps of dark matter ever produced. It shows how the invisible, ghostly material overlaps and intertwines with regular matter, the stuff that makes up stars, galaxies, and everything we can see. Now, published Monday, January 26 in Nature Astronomy, the map builds on previous research to provide additional confirmation and new details about how dark matter has shaped the universe on the largest scales. Galaxy clusters millions of light years across that ultimately give rise to galaxies, stars, and planets like Earth. Now, this is the largest dark matter map we have ever made with the Webb, and is twice as sharp as any dark matter map made by any other observatories, said Diana Skogna. Oh, good golly. Anyway, Diana, the lead author from the paper of the astrophysicist at NASA's Jet Propulsion Laboratory in Southern California. Previously, we were looking at blurry picture of dark matter. Now we're seeing the invisible scaffolding of the universe in stunning detail thanks to Webb's incredible resolution. Now here's a comparison between what we're seeing now in the Webb with James Webb scope versus what we saw with Hubble. So some dark matter structures appear smaller in the Webb data because they are coming into sharper focus. And that makes sense. If I'm looking at the moon or a star and it's out of focus, it's going to be bloated, right? So Webb's higher resolution also makes it possible to better confine the size and location of the dark matter clusters in the lower left of the image. Very cool. All right, so let's move on to another one. So dark matter doesn't emit, reflect, absorb, or even block light, and it passes through regular matter like a ghost. Just think of Jacob Marley visiting Scrooge. But it does interact with the universe through gravity, something this new map shows in a higher level of clarity. Just 3 days ago, this crosses my phone screen. So what you're looking at here, excuse me, is M87 and its cosmic blowtorch, like jet, as seen by the Hubble Space Telescope. Using the Event Horizon Telescope, astronomers have tracked a 3,000 light cosmic blowtorch back to its source, the supermassive black hole M87, which began. A sec now, I got to open up my screen because it's not showing me everything. Maybe we'll do it here. There we go. Which bears the distinction of being the first black hole ever to be imaged by humanity. And remember this photo from 2019? That was the one that was M87 and the black hole. So M87 sits at the heart of the galaxy Messier M87, located around 55 million light years from Earth. This historic image of its supermassive black hole, which has a mass equivalent to that of 6.5 billion suns, was captured by the EHT in 2017 and was released to the public in April of 2019 and covered by the Sunday Night Astronomy Show. Yes, we did cover that. Not only is its supermassive black hole more massive than one at the heart of the Milky Way Sagittarius A, which has a mass around 4 million solar masses, but M87 is also an active black hole. That means it's greedily devouring its surrounding gas and dust, as well as launching powerful jets from its poles. And unlike fussy people who only want white turkey meat, a black hole gobbles everything, including dark matter. As fabulous as this capture is, the exact source of these jets around their black hole central engines and the precise mechanism powering them remains a mystery. And although this year is not a leap year, thinking about 3,000 light year long blowtorch, I had to include this. It took until February, but I finally got all the distances updated. I really wish we didn't have to do this. Astronomers hate leap years because they make light years 0.27% longer. And that's this week's. Oh, it won't play the sound, but Rosanna's fun.
Yeah, you'll have to sing it if you can't play it. Awesome.
There
Wow.
you go. Now there is some pretty crazy information.
That
And it's
information-
amazing how, as we're progressing with our technology, our camera technology, our space observatory technology, how we look at something and now we see it totally differently, and we see it with so much more resolution that even maybe perhaps some of the mass that we thought it was at one point maybe isn't what we thought it was. So that always brings me back to that. Astronomy is theory at its best.
Oh yeah.
It's because we really don't know, only based on what we think we know. And it just seems every time we advance with technology, we start to discover, well, we might have been wrong about this.
Yeah.
Because
Yeah.
this now has been discovered and this reveals this. So anyway, that's what keeps astronomy so interesting, because it's ever changing. Because again, it's based on theory, a lot of it.
We'll only know if we go to the moon and the footprints are gone.
There you go. That's right. Those woody
You
prints are gone.
notice they never go back to the same place twice.
Anyway, thank you so much, Rosanna. That was absolutely wonderful. Enjoyed
Absolutely.
it.
Thank you very much. Yeah, that part about the spacecraft with the other piece on, I was on ESA's site myself the other day, and I was just looking for if they had put out new images or anything
Yeah.
recently, and that same story came up. I was
Yeah.
sitting there thinking. I actually typed into Google. I said, "How big would a circle have to be to cover the sun, so you may have an artificial eclipse, like you and I on okay,
Yeah.
we're going to have one for you this week and whatever." But it was just massive size, right? And it couldn't be done really, not feasible today anyway. But
No.
yeah,
Isn't it funny how, when we think about distance, and, I guess you'd have to be a bit of a physicist, I guess, to a point, or somebody smarter than me, which wouldn't take much. But if you took your baby finger and extended it out, you can cover the sun. But you can't eclipse it. But yet the moon can eclipse it. You know what I mean? So it's just like, but the moon is the same size as the sun. So again, it's only this tiny little thing in comparison to, to us and our perspective of it.
right. It's that shadow that the moon casts back into space, right? So
Oh no, there's no question, and we're in the shadow. It's not covering the whole surface of the Earth, but we're in the shadow. But it's just big enough that, and far enough away that it casts a big enough shadow that we can do that.
yeah.
But for a simple person thinking about it, well, why can't I just cover it and get the same effect? Right? Anyway, it's all fun. It's all fun.
Okay, well, let's go to some more fun. Thank you, Rosanna, for that.
Yeah.
Amazing information. Okay, I'm going to try to switch screens here. It's probably going to freeze everything up again, but hang on.
That's all right. It's cold. It's winter. We're supposed to freeze.
It is.
Part and parcel of what's going on. So, good news is that storm is going to miss us. Maybe not Nova Scotia. Sorry for your luck down there, but I think we're going to be okay. I think.
I think so, too.
Yeah.
Are we up? Lynn?
Yep.
We are.
Okay.
La Lune.
Let's start off with a few photos then.
Okay.
These are from Mark. Mark Ficken is here. He said, "Hi Chris, more content." He said, "Imaged under frigid and full moon conditions here in Bronte with the Sea Star S30. Now the moon is a single shot and edited in the phone. This one here, M35 and M37 were shot in 4K at 30
nice.
seconds and 60 seconds.
Yes, sir.
M36, am I on the third one or am I? I was looking down. Yeah, okay. M36 and M38 mosaic includes NGC 1931, IC 417, and NGC 1907.
You know what's neat about these clusters is they're very observable in a telescope.
Mm.
You can see there's not much different from what Mark's showing here off his photographs.
Yeah.
Yeah.
You can really see
And they're
those
very
clusters.
close together, so it's easy to find them all.
Exactly. Yeah.
Yep.
Exactly.
Those ones are, yeah, for sure.
Yeah.
Thanks for those, Mark. Okay, gonna move from there to, oh, there's the other one, sorry.
There you are. Yeah.
That's it, yep, that's the last one. NGC 1931, IC 417, and NGC 1907.
Very nice.
They never get
clusters.
old.
Okay, gonna move to Kathy Adams' capture here the other night with the moon, one day before a full snow moon.
That was tonight, wasn't it? Yeah.
This would be last night, so yeah, tonight's
Last
a
night.
full snow moon. Processed in mono, as we see it, and also in mineral.
We're just cloudy tonight. Oh, nice.
It's nice. Both of them are nice.
Yeah.
Nice job.
Yeah. I like the mineral one actually better.
Yeah.
I couldn't get it to
Let's
focus.
go
last
back to
night.
the mono one and go to the mineral.
No, I assume
The
that's
mineral
mono.
one's got so much more depth to it.
Yeah.
Oh yeah,
Yeah,
that's awesome.
I said I couldn't get the moon to focus for me last night.
Yeah.
No?
I don't know if there was a haze in there or something.
Yeah.
Yeah.
It must be just pockets because it was funny. We were driving back from Midland, and at one point I had the big, circle around the moon. I thought, oh, I'll get home, I'll take a shot of it. About a kilometer down the road, it was gone. So it was just a pocket of haze, right?
Yeah.
Yeah.
Anyway, that's nice. I like it.
Nicely done.
job.
Bob Simmons got this one, M42 and NGC 1977, Orion
Yes, sir.
in the Running Man Nebula, using a Dwarf 3,
Oh.
188 by 1 minute subs at 40 gain, Bortle Fuller skies, astrofilter and dual band half each. I used Serial, Verilux Suite, StarNet, Aberration Remover, and Affinity Photo 2.
Wow.
Nicely
Look at that.
done.
Look at the detail, eh?
Mm.
Beauty.
Very nice.
Okay, I'm going to go
It's the
from there.
season for that target, eh?
That
Oh,
is,
yeah.
you're right.
You want to get this one, get out now because she's starting to move on the other side. So
So I got this other one in, and it was from Barb Era. And then I got thinking, okay, there's another shot. Okay, Barb Era.
here we go.
And I was thinking, Barb Era, that's a strange name, Barb Era. Barbara.
It's the white shirt. It's the white shirt you're wearing, Chris.
You can look her up, and it's Barb Era, but why is that name? Why does that name not sound right?
That's good. She's from another era.
Yeah.
Nice shot,
Anyway,
though.
beautiful, amazing lunar halo, though. Yeah,
Yeah.
awesome. Thank you for
Now,
that,
why did
Barb
she
Era.
take that? Because that means the storm's coming.
That's
Yeah,
all.
that was the other night. Yeah, tonight she said, so that would have been Friday night, I believe.
Right on.
So thank you, Barb Era.
Yeah.
Oh, nice.
Here's one from Isabel Elliott. She said this was taken at 10:45. Moon was too bright to see much closer. This was when Moon and Jupiter were close together, so I think that was Friday night as well.
That's
So
nice
Oh,
shot.
that's cool.
yeah, still nice
I
shot.
love the
though.
perspective.
Yeah, that's what I thought. Cool.
Is that now? Is that Jupiter by the stick, or is that a reflection of ice?
I think it's
That,
right there.
Yeah,
Maybe right there.
It looks like Jupiter. I think it is.
yeah. Okay,
So anyway, you got it.
right on.
Nice to get it and get the shot.
Yep.
This one from Andrew McDonald. Nice to give us Moon.
There we go.
Thank you, Andrew.
Yes, sir.
And one here from Ann Driscoll as well. Nice Moon.
Any day, nothing nicer.
Yes, sir.
Nice
I
shot.
got this one from Marianne McKillen Jeanette.
Fun.
So there you go. There's a moon in the middle.
There you go. That's cool.
That's so much fun. Look at that, eh?
Yeah.
Oh, that's
Perfect.
awesome.
Thanks for that, Marianne.
That's an awesome photo.
Yeah, it is. Yeah. That's what it's all about. Having fun. This one from Brad
Yeah,
Perry.
that's definitely Brad's.
That's pretty.
Yeah.
Very pretty.
The almost full moon setting behind downtown Fredericton on January 31st at
That's right.
7:06 a.m. So yeah,
Yeah,
you can get a nice morning moon like that, boy. Yeah.
that's really nice. Look at the distortion in it, eh?
Yeah, it's crazy. Coming through the clouds.
He frames stuff so nice. Yep.
Yeah,
Well done, Brad.
yeah, absolutely.
And I think I'm going to go to Mr. Paul Owen's capture here, Jason Aurora and Hammond River.
Yeah,
Wow,
that was the
mm.
night. That was the second night of the aurora,
Mm.
and I got there just a little bit late, so all we had was that green horizon haze, and I happened to see the Big Dipper up on its side.
Yeah.
It's kind
You
of
know.
right,
Yeah.
Yeah.
and but that's right at the that little bridge in Hammond
Yeah.
River.
I
Yeah,
know
right
right
there.
there. Yeah. Okay. Yeah.
So anyway, I've discovered a new place. If you want to go get some star trails, that would be a really good spot right by in front of that bridge.
Yes,
Because
sir.
that is facing north, because that's the Big Dipper to the right of Polaris, right?
Yep.
So right over the bridge is due north. So that's a great spot to get star trails.
Yeah, right on.
Yeah.
There's the bridge there. Yeah. Yeah.
Yeah.
Beautiful.
Yeah.
Nice job.
No, thanks.
And this one from Mr. Powell, the Moon and Jupiter, Friday night.
Yeah. It was hard to get because, like you say, the moon was so bright.
That's
Yeah.
Jupiter way down the bottom, Mike.
Yeah.
Moon and Jupiter, yeah. I wanted to get them in the same field of view.
Yes,
That's
sir.
We got a
150 millimeter.
we got a number of really nice conjunctions coming up this year: Mercury, Saturn, Moon, Mercury, Venus, and Saturn. But they really don't start till sometime in June. But these are nice as well. I mean, the Moon kind of visits the planets across the sky every month anyway. But
Right, too, because they looked a whole lot closer than they really were.
yeah, yeah,
It's funny when you start trying to capture them on camera how far they are apart.
Yeah.
exactly. All right, and so if you have any images to send to us, we love sharing them. Please send them into astronomybythebay@gmail.com, and we'd be happy to put them up on our next broadcast. We will so. Okay, let's have a look at what's coming up this week. Just a couple of things tonight. Actually, there's a transit of Europa in its shadow. Now, this is the times when Europa's or Jupiter's at its best, so we get an opportunity to get a lot of these happening, these transits. Tonight, Europa is going to transit across Jupiter from 2037 to 2327. That's Atlantic time, and its shadow will follow behind from 2144 to 2435.
There's lots of time to look at it, eh?
Yeah, through a few hours there, right? So yeah, these are always nice to see.
Mm.
Monday, February 2nd, the moon occults Regulus. So there you go. That's a kind of a nice little view. If you can catch it just on time, the time is going to start at 21:58, so a few minutes before 10, and then it'll last until 23:05.
Oh, before it comes out the other side, you mean?
Right.
Yeah.
Yeah.
Yeah. But it'd be interesting to try to catch that in time lapse going into it. That would be
Yeah.
nice. Those who
Yeah.
do time lapse photography.
Yep, and there's going to be a really nice one of these coming up for Jupiter. Actually, it happens twice. One in daytime, one at night. For Jupiter to pass, to be occulted by the moon later on this year. So that would be a nice one to go live with.
Yes.
Wednesday, February 4th, and there's another transit of Io in its shadow. Io's a tinier moon, a little bit closer to Jupiter, from 2320 to 10133, and the shadow from 2357 to 214. So still lots of time to catch that as well.
You know who got a really nice shot of, and it might have even been a double transit, was Emile Cormier.
Yeah.
When he was doing all the planetary work, he was using it capturing it with his Dobsonian, and actually it made Sky News magazine,
Yeah.
and really really nice. I wonder if maybe reach out to him, get him to maybe send that photo in because it was such a really nice, just to show you what you can do right here from our little pocket of the or surface of Earth with a little telescope. What you can actually do to get these things because there's not that hard to do.
Yeah. Well, look, I mean, if I can do it like this.
Yeah, that's what I was going to ask you after how.
Yeah, well, it's,
But now that you brought it up, how did
Yeah.
you do that?
well, the hardest part was getting the lines on there and the names.
Yeah. I was gonna say I didn't know they had
They're really hard
crayons
to
that
read.
color.
Yeah, they're really hard to read in space.
Oh, that's funny.
Oh, here's another one. Friday, February 6th. Transit of Io in a shadow again. So get 2 chances this week with Io. From 1746 to 2002. And it's shadow from 1826 to 2042. So
For those people who really enjoy planetary astrophotography, Christopher Go and Damian Peach are the 2 guys. You can just look them up. They've got tons of stuff they do. And it wouldn't surprise me if some of the stuff wasn't theirs. But that's how amazingly well they capture this stuff. And that's they specialize in it, and so if you like that kind of stuff, go on to find those. Go look them up, Damian Peach and Christopher Go, and you'll see some amazing planetary astrophotography.
Yep, you're right. Okay, we're going to get to our 2 calendars. This was a brand new one. Hey, Lisa. Lisa's Look Up Astronomy and More sent this one in to me. This is her events in the far left, the dates of the events, the peak times, and your seeing tools, your naked eye, binoculars, or a telescope. This is brand new from Lisa. She rushed to get home to get this one to me, so I appreciate it. So we can find Lisa at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and now on Blue Sky. Thank you, Lisa.
Very nice.
This one, our January, February calendar, 6-week calendar from Kurt Nason, local guru astronomer. You can find this calendar at sjastronomy.ca or rascanb.ca, and this is our week right here. So Moon Occultus Regulus, there we are. There's the zodiacal light actually starts on Tuesday as well. So there's lots happening here. So go to sjastronomy.ca. While you're there looking at all the other stuff, you can download the calendar there for free as well.
There's close to 11 shadow transit potential things on that calendar.
Yeah.
So if you want to check those transits, you get lots of. This is a good month for it.
Yeah, absolutely. Okay. I think we're back. I'll bring us back. Zoom here. Here.
Yeah.
So, yeah. So we're at 8:55.
Oh,
Oop.
where'd Mike go?
Oh, where'd Mike go?
I think he ran out to get the coffee for us. No, he's back. That was fast.
Ta-da!
Must have only had 1 car in the drive-through.
Auto detect. Yes.
If I could, we got a few minutes, so if I could just take a moment, make a little plug for myself, if I could.
Sure.
I have another channel that I host, and it's for anybody who was into photography, not necessarily astrophotography, but just photography in general. And it's called Snapshots and Stories, and I've been doing it for about 8 months now, and getting things kind of ironed out and working good. It's a half-hour show, doesn't take long to watch, and it's about everything photography. So if you want, I do a lot of tutorials for editing with Photoshop and Adobe Camera Raw. We talk a lot I bring special guests. Matter of fact, I had Brad Perry on just 2 weeks ago. He was on. We had a nice chat. And I bring photographers, like people who shoot horses. That don't mean shoot horses, but take pictures of horses. And, I've had all kinds of different types of photographers that come on. And we chat about photography. Lots of times we'll just do some picture evaluations and that kind of stuff. So it's just a nice, easy half-hour thing. So if you are a photographer and you like to look at that kind of stuff, look us up, Snapshots and Stories. We're on YouTube, Facebook, and Rogers TV. So, So anyway, that's my shameless plug.
No problem at all. Yeah, I've seen a few, I see that. I see them myself. I've been on looking around at them. So yeah, they're very, very detailed.
Yeah.
Great to have. Okay.
Oh, by the way, anybody that's interested in trying to capture the ISS going in front of the sun on February 2nd, or sorry, February 6th at 5:08 at night. If you set up in the St. John area, you might be able to catch a transit of the ISS across the front of the sun.
Cool.
Make sure you
Yeah.
get there early and get your stuff set up because it will go by so fast.
Yeah. Last time I tried, my battery ran out 15 seconds before the.
Yeah, and you weren't upset either. I remember.
Yeah.
No.
You can go online and just type in and AI will tell you exactly how to shoot it if you want to know how to do it. You just got to have a really fast frame rate camera. That's and a you know you need to have a good focal length.
The easiest way is take an HD video and pull the frame.
Yeah, but you still need to have a long focal length
Oh,
to
yeah.
see it to begin with.
Yeah, yeah.
And then you can do a video from it and yeah, and just pull your frames of whichever ones that you want. But it happens like it's extremely fast. You got to have a really fast frame rate to be able to pick it up because it's just like it's there, it's gone.
Yeah.
So if you want the information, you can go on transitfinder.com and it'll tell you exactly what it's going on.
Yeah.
Awesome. Thanks, Mike. I'm going to shamelessly put a plug in too because today is my 10th anniversary for Astronomy by the Bay.
Yes.
Happy birthday.
10 years. That's a decade. That's a decade.
On Facebook with my posts and stuff. I mean, I've been in the hobby, I guess, 20 years now, but and outreach a little bit before that. But this crowd has really been awesome for me. I've really enjoyed the experience. Like I put in a lot of hours into putting up posts. A little over 6,000 posts now in 10 years. But the audience has been so great. We built a nice little community. You know, it's not just me. It's everybody else joining in with me. So if I talk about Aurora, I got 50 pictures of Aurora coming up, or we talk about the moon, and there's everybody's just so open to contribute to the page. It's just and it just keeps it rolling. Like it just keeps it going. So I'm very, very, very grateful for everybody who's been following me through that means right along for the last 10 years. And let's keep going, I guess. We got a whole lot more to learn together.
You know what? There's a lot of people out there that are grateful that you're doing it because I know a lot of this was started back just before the pandemic, actually, and then it hit, and then this thing that we do was a part of it, not a part of you, but more a spawned thing from it. And but there's so many people that follow you, and you can tell just by the support that you get from everybody that they really appreciate everything that you do for people, because I mean it's a lot of people just can't take the time to jump into it the way that you do, but because you do that, it makes it nice for them and easier for them to be able to get that quick information. And a lot of people are really appreciative, including myself, when you're, especially since you started the solar watch for auroras, to get out there and be warned of those things. So anyway, so from me, thank you for doing what you do, and I'm sure the audience out there I really appreciate it. So as much as you're thankful for them, they're just as much thankful for you.
I appreciate that, and looking forward to carrying on with it because it's been exciting. As I say, just this community. I'm the biggest introvert you would have ever thought. Me doing this, even this right here is hard, really difficult. But to be sharing all of my hobby, who gets to share their hobby with 25,000 followers? I'm pretty blessed to be able to share a hobby just that way. But I've always had a real high interest, and I've always had a high interest to try to teach people too, or share what I know, which isn't much, but it's still great to share. But thank you all again for following me and I really do appreciate all of you, every one of you. Thank you.
So we're expecting payment soon.
Yes, of course. That's coming. It's coming. Yeah, checks in the
The
mail.
membership card.
Checks in the mail. Okay, so in closing tonight, we'd like to thank you all for joining us again. Special thanks again to Rosanna for fun facts. Awesome fun facts there again, Rosanna. Thank you once again. To remember, we do love getting your photos, to send them into astronomybythebay@gmail.com, and we'll be happy to include them on our next broadcast. And we're always looking for ideas for future shows. We can't keep coming up with these. Bring them out. Let us know.
No.
So just send them to the same address, and we'll be do our best to try to make that happen for us. Well, so for now, then, from Mike, Paul, Roseanne, and I, wish you all clear skies this week. Not going to get them tonight, but I think the rest of the week might be good. As we like to say, though, guys, open your eyes to view the skies and keep your scopes pointed
Pointed
up. Good night, everybody. Thanks for joining us.
Right.